Okay, class, I wanted to resend, rework the problem that we did towards the end of class. Actually, Becca had a question on it, and I went back and I looked at the original problem, and I realized I had it down as a piecewise function, and actually it was not a piecewise function. So let's review this again, and I apologize for writing down the wrong problem. So here's your rational function. And you're asked to use the continuity theorem to determine your intervals on which the function is continuous. So you want to use the continuity theorem on rational functions and come up with intervals where it's continuous. And Becca, after you asked me if it was a whole, I realized that I didn't have a piecewise function on the board. So I'm so glad you asked the question. And I want to clear up, let me erase this. I want to clear up any confusion that you might have with that. So we have to look at the denominator. A lot of the preliminary work is the same. So we're going to look at the denominator. We're going to set it equal to 0. And your points of suspicion, and I'm going to call them that, so your suspicious points are x equals -1 and x equals 1. Okay, so go through your continuity checklist, and this is where we had some problems. Using the continuity checklist, let's go through the point. I'm going to put it in orange. This is where I made the mistake in class, thinking it was a piecewise function. So at x equals 1, evaluate the function, and you see that it does not exist. Hold on. Sorry about that. So it does not exist because when you put 1 into the function, the original function now, right, you get that it's undefined. So it doesn't exist at 1. Therefore, don't even bother continuing down the checklist. You know it's not continuous there. It's not continuous at 1. So what I'm going to do is look at actually, you know what? I think I will continue to look at the limit. Yeah. The limit. Hold on, another pause. It's a busy time. I wanted to just go through and factor and let you see that when you do factor this, and this is where Becca pointed out, right? We have a whole here at x equals 1. You know, that's definitely a whole. So therefore, since it's a whole, okay, and it's not defined in another piecewise function, right? If this was defined in a piecewise function, right, with the rational, and then for x equaling 1, right, if this thing was given a value, then we have something to work with. However, this was not the case here, and the value ended up plugging the hole back up, which is what I was trying to explain to Becca, but that's not the problem we had here. Here we had a pure hole, therefore, right, it's discontinuous. It was not plugged back up with a piecewise definition. So it's discontinuous. And it's also discontinuous at -1. All right, for the same reason. So, oh my goodness gracious. I'll never get this video done. Hold on, please. Okay, so at x equals -1, we have the same problem, right? Because f of -1 does not exist. So the bottom line is this was not a piecewise function. This was a straight-up rational function, and the intervals of continuity are defined about those discontinuous points. So it is discontinuous at x equals -1 and x equals 1, and this was not a piecewise where the hole was plugged back up.